I will continue from the problem solving on vectors. So this is the 8th problem that we will start with. This is if the difference of two vectors and the mod of that difference is equal to, this time it is, earlier it was plus, and the equation on the right hand side was same, this time it is minus. So then what is the angle between A and B? Okay, so A minus B is nothing but, if I take the resultant, A square plus B square, that is minus B square basically, because this is nothing but what, A plus minus B, and negative vectors, so minus B, then 2 into A into, I will say, minus B into cos of theta. Theta is the angle I have taken between the vectors. Okay, now theta I have to calculate. This is nothing more than that, and that separately is this value A and B you can write. Now square it of both sides, it will give A square plus B square, and this minus will turn it to 2AB cos theta is equal to A square, square it of, I will get A square plus B square plus 2AB. That's it. Now here this will be cancelled, so I will get 2AB plus 2AB cos theta is equal to 0. Taking 2AB common, it will be 1 plus cos theta is equal to 0. So either this will be 0 or this will be 0 to be a product is equal to 0. Now this 0 means either A is equal to 0 or B is equal to 0. So A is equal to 0 means this is null vector, this is null vector. So this is all, this thing is true if it is a null vector, but in that case I cannot examine the angle between, because one is a null vector and another is a vector, so I cannot say the angle between. So this is undefined if I say, so this is not possible in this case. A is equal to 0 or B is equal to 0, because null vector to any vector I cannot say the angle between them. So rather I can say this is not a possible condition. So the only possible condition is 1 plus cos 2 theta, cos theta is equal to 0. That means it is 2 cos square theta by 2, because why do you know 1 plus cos 2 theta is equal to 2 cos square theta. Okay, now if it is instead of 2 theta it is theta, that means it will reduce to theta by 2. So that means cos theta, ultimately cos theta by 2 is equal to 0. Cos 0 means cos 90. Okay, now that implies theta by 2 is equal to 90. This implies theta is equal to 180 degree. Okay, so angle between this is equal to this. So A minus B, if I say this is A minus B is equal to, magnitude wise A plus B is the case if that is theta. Okay, basically. So from the sum it is coming like that. Cos 2 theta is equal to 0. So I am saying it is 2 cos square theta by 2 is equal to 0. So cos theta by 2 is equal to, cos 0 means cos, cos 0 means, 0 means cos 90, it is right. So theta by 2 from here it is 90. So theta is equal to 2 into 90, that is equal to 180. For 180 degree, this will be the condition. Okay, the angle between the, it will be 180. So the next, it is number 9. P and Q vectors are two adjacent sides R2 adjacent sides of a parallelogram. Parallelogram if P plus Q is one of the diagonal, then the other diagonal is what? So you have to establish a relation between P and Q for the other diagonal. So if I assume this is the P and Q, this is P and Q, okay, P and Q, and if it is following the parallelogram, so this will be the two arm, the adjacent arm. So the diagonal, if this denotes, because this P plus Q, because parallel vectors, I am shifting into parallel, so I am not changing the direction. So Q plus P is equal to the resultant, if it is say R1. So other diagonal will be how much? Let's say this is R1. So R1, how will I get? Either these vectors, if I have to establish the relation, so this is in a different direction. So even if I take this triangle, so if I reverse it, so P minus Q, this vector will denote this diagonal in the reverse direction. Let's say this is R1, I am saying it is positive, or else this could be on other possibilities. If I don't change it, rather I change it, means minus P. So this case Q minus P vector also denote that diagonal in the magnitude, and direction will be opposite, that will be minus R1. But here it is saying if it is diagonal, it denotes, because I don't know which way the result will come. So both this thing, if I take, would be possible. Both the results is possible, because that denotes some vector and that follows the triangular law. So the both that thing, unless and until that is said that resultant is this way, this both the resultant is correct. So for any case, if it is option is given P minus Q and both Q minus P, so the both answers are correct. Okay, because I never know what is the direction of P and Q. If it is known P and Q direction, then definitely I can say what is the answer. But otherwise, I can assume any answer according to my assumptions. So P and Q are two vectors only, represent the two. So this the reverse one will be minus P, this will be reverse. So I can take either case, minus P or Q. Okay, so this way, this both answer P minus Q or Q minus P, both will represent the other diagonal of the parallelogram. This is problem 9. Now to 10. A plus B is equal to A minus B. Then find angle between A and B. Okay, so as per formula, if I say both sides as root will come, so I directly overlooking the roots and writing the equation or the expression on the both sides, it will be basically 2AB, and theta will be same, because AB are the two distinct vector, and if that represent the same vector, both the case, for this case and this case, the angle between the vectors has to be same. So here also I will put theta, here I will put, so both will be same. So this will be cancelled out. So all together 4AB cos theta is equal to 0. So on the same logic, in the earlier logic, a cannot be 0, b cannot be 0, because any vectors with a null vector cannot decide the angle. So I cannot take this. So rather cos theta is equal to 0. That means cos 90 degree. Sorry. Yes, cos theta, cos 90 degree will come. Here nothing is coming extra. So cos 90, so theta is equal to 90 degree. So in case of two vectors are in 90 degree, so the this part means a plus b. So what is that? If I say it is a parallelogram, is basically a rectangle 90 degree. So a plus b, the resultant, if we say, now if I take a minus b, so minus will be this side, and if I complete the rectangle, so this will, the result will be this. So this resultant and this resultant will be in how much? This will be in 90 degree apart to each other, but this magnitude wise, this is to the same, because I am talking about the magnitude. The magnitude of a plus b, it is whatever will come r, the magnitude of a minus b also, but only the direction is same. So vectors will not be same, but the magnitude will be the same. So that condition is when theta is equal to 90. That means two vectors are acting 90 degree to each other. Okay. So moving to move to the problem number 11. It says if the resultant of P and Q makes angle theta 1 with P and theta 2 with Q, then out of the following condition, which are correct, which one is correct? Rather, theta 1 less than theta 2 if P greater than equal to Q, theta 1 less than theta 2 if P greater than Q. Third, theta 1 get less than theta 2 if P less than Q. Or 4, theta 1 less than theta 2 if P is equal to Q. Now to decide it, as you know, let's say these are the two vectors. I assume this is Q, this is P. Okay, now when they will form a parallelogram, this will give the resultant R. This is the angle the resultant will make with Q. That means this is theta, and with the Q, this making theta 2. Now, one thing I have to explain. Now, if this is the case, I generalize, I will express, then you understand any of this. Now further, if I, let's say, increase this vector, let's say from here it is increase this, so what will happen to the rectangle? It will move up to this vector is same. Okay, so now what will be the condition of your new resultant here? Okay, now see, just understand very minutely. Now I am increasing vector P from, let's say this is new vector is denoted by P1, which is, so P1 basically more than P. So again, so if I increase, then the resultant R from R1, say, what would be the angle here? New angle, let's say this is theta 1 dash and this is the angle theta 2 dash. So now we can say that theta 1 dash is lesser than theta 1 and theta 2 dash is more than theta 2. This new angle of theta 2 increasing due to the resultant is more leaning on the ground, towards ground, as because P this vector is increasing. Okay, so you can say when the horizontal vector is increasing, the resultant is coming closer to the horizontal vector, and on the other hand, if I increase this one, the new parallel of this, so this vectors, the new position will be here. So here theta 1 will increase and theta 2 will reduce, because earlier it is this much, now it is this much. So you can say if P increases, theta 1 decreases. If Q increases, then theta 2 decreases. So the angle which is the resultant is forming with the vector, if this vector is itself increasing, so the angle reducing. So this is I am telling just to build a concept. Now I will discuss about a fixed position. Now tan alpha, the angle formed by the resultant with this horizontal vector, is given by, if it is Q, this is P, so I will take Q sin theta. Theta is the angle between the vectors, P plus Q cos theta. Okay, now here what is theta 1? Theta 1 is the angle made with the horizontal vector P1, and alpha is the angle. So alpha is the angle equivalent to theta 1. Here alpha equivalent to theta 1, and theta is equal to, theta is the angle between the vectors, so that is theta 1 plus theta 2. Okay, fine. So now I will come to a condition. If say P is equal to Q, one boundary condition I am taking, P is equal to Q, that means two vectors are having same magnitude. So mostly this will be a parallelogram, but it is a rhombus kind of parallelogram. This is a limiting condition. So for P is equal to Q, what I will find, tan of alpha, if I eliminate this, on the top is will be sin theta, bottom is equal to 1 plus cos theta, because all will be eliminated, P, Q are same. So from here you can come to the point where this will become, because how it is coming, I am showing it, let me rub it, because on the top it is coming tan alpha is equal to sin theta upon 1 plus cos theta. So that is equal to 2 sin theta by 2 cos theta by 2, and this is 2 cos square theta by 2. So if I reduce it, cos 1 cos will reduce, so that will be sin theta by 2. So from here I can say alpha is equal to theta by 2. That means alpha is what? Alpha is equal to theta 1 here, and theta is equal to theta 1 plus theta 2 by 2. So if you calculate from here, you can get theta 1 is equal to theta 2. So this is a boundary condition where if P and Q are same, P and Q are same, means P is equal to Q, then theta 1 is equal to theta 2. So it will be a condition where if two vectors are same, then their resultant will form a equal angle with the vectors. So this is also P, or you can say this is Q and this is Q. So this will form theta and theta 1. So this is the primary condition. So now for any case which will be P more than Q, if I say if P more than Q, then what would be the condition here? I have to divide it with Q. So the top will be sine theta and bottom will be P by Q plus cos theta. So P by Q is what? P by Q is equal to greater than 1. So you can understand this equation, this is greater than 1, this is limiting up to maximum 1 and this is also limiting up to maximum 1. So this ratio is always be less than 1 for case of P greater than 1. So this, if it is less than 1, that means alpha is always less than 45 degree. So what is alpha here? Alpha is what? Alpha is theta 1 here. Already I have assumed that alpha is the theta 1, that is making degree with the horizontal. So alpha, if it is less than 45 1, so we have seen for 45 degree of this means where it is coming 45 degree, when the two vectors are 90 degree to each other, then alpha only come 45 degree. And one thing I have said that in case P is equal to Q, the limiting condition P is equal to Q, then only the vectors make equal degree. For any increment of P, let's say I am just increasing the P value, so what would increase here? That I have explained. If P is increasing, this vector is increasing, so this will be more steeper. So Q1 will increase. Up to P is equal to Q, Q1 is equal to Q2. Now increasing P, so then Q1 will increase. So Q1 will always be greater than Q2. So if I increase the P, means P is more than Q. Up to the limiting condition P is equal to Q, your theta 1 is equal to theta 2. That I have calculated here. But now if I increase P, these vectors if I increase, means this vertical vectors, if I increase, though the resultant will go steeper, so theta 1 will increase. So then theta 1 from equal, that will get an increment over Q2. So this condition, the first condition say the Q1 less than Q2, theta 1 less than theta 2, if in case P is greater than equal to Q. But for Q is P is equal to Q, or sin theta 1 is equal to theta 2. So this cannot be a condition. Okay. Now the second condition was what are the ultimate thing I have got? If P is equal to Q, that is the standard theta is equal to theta 2. Now further, if I increase P we have taken the horizontal this side. This is Q. Now this is the limiting condition. This is Q vector, this is P vector. So this is the limiting condition. As P is equal to Q, theta is equal to theta 2. Now any increment of Q, this will move to a larger rectangle from this. So from there, resultant will move into this. So theta 1 increasing, theta 2 decreasing. So P if it is increasing, Q if I increase, then theta 1 will more than theta 2. Theta 1 will increase if Q is increased, and if P is increased, then P is increased, the resultant will go here, theta 1 decrease, so theta 2 greater than theta 1. Understood? That means here not only increment Q greater than P, here P greater than Q. These are the three conditions can avail the system. This is the ultimate pivot point. From whichever way it will move, accordingly the thing will change. Now the condition says, first condition in the question it is said Q, theta 1 less than theta 2 if P greater than equal to Q. Is it possible if I say P is equal to Q, theta, so this doesn't help. P greater than Q, P greater than Q, theta 2 is equal to theta 1. But in this case, P is the resultant and Q1 is the angle, okay, with P and theta 2. This true, but this half true, that cannot be. The second condition, theta 1 less than theta 2 if P greater than Q. If P greater than Q, theta 2 greater than theta 1 is okay. So this condition is okay. Let me check the third condition. If P greater theta 1, the first one, theta 1 less than theta 2 if P less than Q. If P less than Q, then theta 1 less than theta 2 is not possible. So this is not the correct option. The last one is P is equal to Q. Then it is saying theta 1 less than theta 2. P is equal to Q is always, this is correct. So this is not. So only correct is this one. I think you understood. So only thing, conceptually, if you understand the parallelogram and their relation, so there will be. So what I have said, this is two vectors P and Q. Let's say this time I am taking P and the resultant is this. This is the initial condition R, making angle theta 1. This is theta 2. Okay. Now I am increasing Q, the horizontal one, from there to there. So this new parallelogram will move up to this and the new thing will move up to this R1. So definitely this theta 1 if I say and this is theta 2 if I say, so definitely from earlier one it has reduced. This angle is less than this angle. So theta 1 is reducing when Q1 is increased. And the other one, if I this increased, this will make new, this will be the new resultant. And this case, theta 1 is this one, this will the initial one. So theta 1 will increase if P increases. Okay. So thank you for now. In the next video, I will come similar one problem and followed by another problem. Good night.